Hey, catch! Don't! Oh!
Kleiny, pause. Oh, this will be fun. This will be fun. So much fun for Woody lads. When you regret the way you've been treating me all these. Oh no! Kleiny, pause.
Oh. No, Woody.
I'm actually dying right now. I'm paused.
Oh, it's so deep down there. Oh my god.
You better get outside now. Your Yeezys are about to take off. I'm not.
What's up? The wardrobe theme for this week is hats from my past. And this week I'm wearing this like Russian stocking cap type thing. There's not really a specific memory that I have attached to this thing. It's just that I was in high school and I think I saw it in Walmart and it made me feel like a Russian. I mean, it's pretty warm. I'm sorry, there's not really a story attached to it. I probably wore it when I went snowmobiling one time. For this video, we're going to dive into ionic compounds, right? This is when multiple atoms come together to form ionic bonds, and they make, multiple atoms together into a compound. So when they come together in such a way that it balances out all the charges. So we're going to learn about that and how you can answer questions and solve problems using that information. So lately what we've been doing is we've been talking about ionic bonds. And so remember, we talked last video about how ionic bonds are caused by a couple of things. They're caused when a nonmetal and a metal come together to form a bond. And so what happens here is that one atom steals an electron from another atom. And because one takes the electron from the other, one atom will develop a positive charge and one atom will develop a negative charge. So let's imagine here that we have beryllium. Beryllium is a metal. It has already given away its electron. It actually gave away 2 electrons, and so now it has a positive 2 charge. And let's imagine that iodine has already taken or stolen an electron, and so it's taken on a negative 1 charge. Well, what we learned before was that these two, since they have opposite charges, are now attracted to one another, right? So they're going to come together. So we have beryllium and iodine here. They're going to come together, but here we're going to start talking about ionic compounds. When these two ions, when these two atoms form an ionic bond, they are known as what's called an ionic compound. And an ionic compound is when multiple atoms held together by ionic bonds caused by opposite charges. So that's what's happening here. But something you should know, though, right, is that beryllium has a positive 2 charge, but iodine only has a negative 1 charge. And so if you are kind of astute, if you are smart, you might realize that this isn't the end of the story. We don't just have beryllium and iodine come together, because there's kind of an imbalance here. Beryllium has a positive 2 charge, but iodine has a negative 1 charge. And so you'll see here that overall, this compound still has a positive 1 charge, because this negative 1 charge from iodine only cancels out 1 charge for the beryllium, right? The beryllium's positive 2, iodine's negative 1. And so here the overall charge of the ionic compound is still positive 1, and this is a problem. right? The thing you need to understand is that when ions combine into compounds, they must balance out each other's charge. And so what we saw here with this last one is that they actually didn't balance out each other's charges, right? There's still overall a positive charge, and that's not balance. A balanced charge would be 0. But here, we still have a +1 charge overall. So I kind of illustrated it here with this teeter-totter, right? Beryllium has a +2 charge. Iodine only has a -1. They're not balanced in terms of charges. Their overall charge is +1. So think to yourself for a second. How can we solve this problem? How can we balance out that last +1 charge? Okay, maybe you've thought about it for a second, and hopefully this is the answer you came up with. Well, what if we just added another iodine, right? Because over here, we have overall a charge of -2. Over here, we have a charge of +2. And -2 and +2 will cancel each other out. They will balance out each other's charge. And so the overall charge will be 0. And so this is actually what happens in real life, is that positive ions and negative ions, or positive atoms and negative atoms, they're going to combine together until they are perfectly balanced. And so actually, the compound that will result here is BeI2. So for every 1 beryllium, it will form an ionic bond with 2 iodines. And so this charge, or this compound overall, will have a charge of 0. And this is how things happen in the real world. Now, what we're going to talk about today, and what I'm going to show you, is how you can take, like for example, I'll give you 2 atoms, and I'll say, hey, if they form an ionic bond, what will the resulting compound be? In this case, the resulting compound was BeI2. It's called beryllium iodide. But I'm going to teach you kind of a step-by-step process in order to figure this out. This process is called the cross and drop method. So let's do this example. What ionic compound will nitrogen and magnesium form? Notice, nitrogen is a nonmetal, magnesium is a metal, so they will form an ionic bond. Ionic bonds are only formed between metals and nonmetals. All right, so we need to find the number of valence electrons for each one. So if you look up the number of valence electrons for nitrogen, it has 5. Okay, magnesium has 2. Then you have to ask yourself the question, will the atom in question gain or lose electrons? Well, we know that nitrogen would really like to gain 3 more valence electrons. All right? It would really like to gain 3 more valence electrons, because then it will have 8. But for magnesium, since it's a metal and it's located in group 2, it is actually going to lose those valence electrons. So, and this is what forms an ionic bond. This is why metals and nonmetals are such good companions, because nonmetals want to gain electrons. Metals, like magnesium, want to lose them. So it really works out perfectly. So let's determine the charge for each one. Well, if nitrogen were to gain 3 more valence electrons, what would its charge be? And in this case, its charge would be -3, right? Because it gained 3 more electrons. What about magnesium? Magnesium would lose 2 electrons, so it would take on a charge of +2. All right? So this is all some stuff we did last week, right? Determining the charge of atoms. Now, what we're going to do is I'm going to rewrite everything. Mg. I'm going to put a little bit of a space here. I'm going to use a couple different colors. So what I'm going to do is I'm going to write the charges on the upper right of the element symbol. So up here we have 2+. Here we have 3-. Okay, those are the charges up there. All right. So what we're going to do next is we're going to cross and drop these down. Okay, so when we cross and drop them down, we're going to drop the 3 down here and then the 2 over here. So the resulting ionic compound that comes between magnesium and nitrogen is Mg3N2. So pretty much what we're saying here is that in order for this overall compound to have a charge of 0, there needs to be 3 magnesiums bonded with 2 nitrogens. Which should make sense, right? Because 2 times -3 is -6. But then 3 times +2 is +6. And so +6, -6, overall those charges balance out to 0. But all we had to do here is cross and drop. And notice I didn't cross and drop the charge itself, I just crossed and dropped the number, right? So and actually, just to make things a little bit more clear here, let me get out my eraser. Just to make things a little bit more clear here, after we cross and drop, we can erase everything, and that is our compound. So when magnesium and nitrogen come together, they're going to make Mg3N2. So let's do another example. This one, I'm going to go ahead and use the periodic table so you can see how to do this. So what ionic compound will sulfur and calcium form? Okay, well, the first thing we're going to do, find the number of valence electrons. Well, sulfur is over here, so it has 6 valence electrons. Okay, calcium is in group 2, so it has 2 valence electrons. All right. Will the atom gain or lose electrons? Well, calcium will lose the 2 electrons. Okay. Sulfur is in group 16. It's easier for it to gain 2 electrons. Okay, so determine each atom's charge. Well, let's do this. Okay, so I'm going to write calcium first, and then sulfur. Calcium, it has 6 valence electrons. Here it is right here. What would happen if it gained 2 more to get to 8? Well, in this case, it would have a -2 charge. What about, that I did sulfur, right? Okay, what about calcium? Calcium is over here in group 2. It is easier for calcium to lose 2 valence electrons, so therefore it would take on a +2 charge. So what I'm going to do is I'm going to cross and drop. I'm going to cross just the numbers, okay? And I get Ca2S2. Now, here's the thing, is that we figured out that these two are already balanced, right? Calcium has a +2 charge, sulfur has a -2 charge. And so when they combine together to form an ionic compound, they're already balanced out. So this is where step 7 comes in, simplify. Well, saying that for every 2 calciums there's 2 sulfurs, that's the same thing as saying for every 1 calcium there's 1 sulfur. So the simplified way to write this would just be CaS. We don't have to say Ca2S2. They're the same. So we can just say CaS. All right, so that is calcium sulfide. That is the ionic compound that forms. One final example here. So what ionic compound will oxygen and sodium form? Okay, so we're back to our normal way of doing it here. So if you look up oxygen on the periodic table, it has 6 valence electrons. Sodium has 1. Now, is each atom, will it gain or lose electrons? Well, oxygen, it is so close to 8, right? It already has 6 valence electrons. So it's going to gain electrons. Sodium is in group 1. It's an alkali metal, so it's going to lose electrons. And so here, in this case, sodium will lose, oxygen will gain. So if sodium were to lose its 1 electron, what charge would it have? And so in this case, its charge would be +1, a +1 charge. Now oxygen, it needs 2 more valence electrons, right? It needs 2 more valence electrons to get to 8. If it were to gain those 2 valence electrons, it would have a -2 charge. All right? So now, at this point, we do our cross and drop. Okay? So I'm going to write Na. Oh, you'll notice I always write the metal first. But anyways, so Na has a +1 charge. Oxygen has a -2 charge. What I'm going to do is I'm going to cross and drop. So I'm going to bring the 2 down here, the 1 down here. We can rewrite that as Na2O. So the ionic compound that forms between oxygen and sodium will be Na2. There's 2 sodiums and 1 oxygen. And notice here that overall, this should have a charge of 0. Okay? This should have a charge of 0 because the sodium is +1, the oxygen is -2, but they should balance out because we have 2 sodiums.